Okay, this is the P4 paper from January 2023. It's question number 4, and as we can see, this is an integration question. For part A, we're actually going to be doing substitution, and part B, once we've rearranged to make that one there, that's going to be an integration by parts. But let's have a look at part A first of all. Part A says, using the substitution, u equals root of 2x plus 1, can we change this integral and make it look like that one there? So yeah, we can. If we go through and do our substitution process, that's what will pop out when we try and do it. So if I'm looking at this function here, what I'm going to need to do using the substitution is change my limits. I'm going to need to change this. I'm going to need to change e to the that, and I'm going to need to change my dx part. Well, the dx part is the part that I always focus on first. You could do any of them, but I always tend to do it in the same order. So in order to get this dx sorted out, what I'm going to do is they've said u equals the square root of 2x plus 1. Well, I can't differentiate like that, so I'm going to call it u is equal to 2x plus 1 to the half, and then just focus on differentiating. So du by dx, if we're differentiating a function like this, multiply by the power, take one off the power, multiplied by the differential of what's in there, and the differential of what's in there is 2. So that's going to give me that du by dx is equal to that. Those two will cancel. I'll get 2x plus 1 to the minus half. Well, that's the same as 1 over 2x plus 1 to the half. And what I'm trying to do is to get dx equals, because I'm going to get rid of the dx there. So if I want to get dx equals, that's going to be 2x plus 1 to the half du is equal to dx. That's gone up there, and that's gone up there. Okay, so I'm happy that I've got my dx part. What else do I need to do? I need to look at these limits here. So if I've got that x is equal to 12, so for limits, anybody who's watched my videos will see I always tend to sort these questions out in the same sort of way. If x is equal to 12, then u is going to be equal to the square root of 2x plus 1, which is 24 plus 1, which is 25, which gives me obviously equals 5 there. I'd be panicking if it wasn't a nice simple value there. And the same for x equals 4. We're going to get u is equal to 8 plus 1, 9. So that gives me the limits are going to be 5 and 3. Okay, so now let's try and sub in. So we've got the integral between 12 and 4 of the square root of 8x plus 4 e to the square root of 2x plus 1 dx that we're going to want to be changing here. Well, hopefully you can see, I haven't really got any problems. If u is equal to root 2x plus 1, then that's just e to the u there, so that bit's okay. Dx we've already taken care of. So this bit here then, I really want that to be root 2x plus 1. So as we go through and do this, let's do a couple of changes here. So first of all, the limits have changed from 12 and 4 to 5 and 3. Now I'm not going to go through the rest of it too quickly, so I'm going to say this is the root of. The only thing I will do with this first bit is I'll take 4 out as a factor. And the only reason I'm doing that is because I want root 2x plus 1. So there's that part there. I'm going to get e to the root 2x plus 1. Well, I'll do that straight away. That's e to the u there now. And dx I'm going to replace by 2x plus 1 to the half du. Just taking lots of different steps to do this. This is now between 5 and 3. Well, square root of 4, that's 2. So I can take that out. That's 2, which would leave me root 2x plus 1. Now, I could have put that straight away as being u if I'd wanted to, but I'm just doing it slowly. E to the u, and then I've got root 2x plus 1 du here. And so I've actually got u and u there. So in other words, it's entirely up to you how many steps you want to do. We just need for you to be getting this right. I've got 2u squared e to the u du. So if we now go back and see what we were trying to get that to look like, yeah, I've got exactly the format that I wanted to for this first part here. So A is completed. Okay, let's have a look at part B then. Part B says, hence integrate that thing. So if I'm going to integrate the root 8x plus 4e to the root 2x plus 1, I'm not going to integrate that. I'm going to integrate this part here, aren't I? So for part B, it's the integral between 5 and 3 of 2u squared e to the u du. Now I'm just going to do something a little bit strange maybe, but I want to integrate this by parts. And when I do integration by parts, I use u's and v's. So I'm actually going to just change this. Doesn't make any difference at all, obviously. If I now say, I'm just going to call this 2x squared e to the x dx. I've simply just changed u for x there, because now with this thing here, I can get about doing my integration by parts. Just like with the last one, let's have a quick look at this function first here. So I've done lots of these. I hope you've done lots of these in preparation for the exam. You should recognize this straight away as not only being integration by parts, but because of that x squared part there, we're actually going to need to do integration by parts and then do it one more time before we go through and get it sorted out. Let's do it because it shouldn't be too complicated to do. So if I've got that, I'm going to say, okay, this is my question. And what I'm going to do then is I'm going to say u is equal to 2x squared and dv by dx is equal to e to the x. When we're choosing those things, I know that if u is that, when I simplify this, I'm differentiating, 2x squared will get simpler. And the key is when I integrate e to the x, that doesn't get any more complicated. So that's the way to make my choices of which one's going to be u and which one's going to be dv. Let's just go ahead and do this now. It's not overly complicated. So du by dx, differential of 2x squared is 4x. Integrating this, well, the integral of e to the x is e to the x. So we can now say that the integral of u dv by dx is equal to uv minus the integral of v du by dx. So that's the integration by parts. If we're doing that, then I'm going to get the integral. I'm supposed to keep the limits in all the way through, 5, 3 here. So the integral of 2x squared e to the x dx will work out to be uv, those two. So that's going to be 2x squared e to the x minus the integral of v du by dx always tends to be the bottom two, the way I set it out. So that's going to be minus the integral of 4x e to the x dx. And then what we notice is that with this part here, that's got a little bit simpler. It started off as squared e to the x, and now we simply have a linear function, e to the x. But I can't quite do that yet. So what I now need to do is to solve this integrating by parts, get the answer for this bit, and then my final answer will be 2x squared e to the x minus, be careful of that minus, whatever the integral of this bit is in a second. So let's just focus on doing the integral of 4x e to the x dx now. And if we are doing that one, we're just repeating the process through, aren't we? So we're going to say u is 4x this time, so du by dx will be 4. Dv by dx is e to the x again, so v is going to be e to the x. So if we do this, the integral, okay, let's just copy that straight down from up here again. So that tells me that I'm going to get that the integral of 4x e to the x dx is going to be uv, which is those two. Uv is going to be 4x e to the x minus the integral of these two, the bottom two, so minus the integral of, in this case, 4e to the x dx. And now we notice that what we originally had was 2x squared e to the x. It went to 4x e to the x, and now it's gone to just 4 e to the x. And the good thing about 4 e to the x is I can just integrate that straight away now. So that's 4x e to the x minus the integral of 4 e to the x is just 4 e to the x. So that's that part there. We're now going to do this thing here, 2x squared e to the x minus all of that. So the original question, which was between 5 and 3, 2x squared e to the x dx, now works out to be 2x squared e to the x minus this thing, so minus 4x e to the x, but plus 4e to the x there when you do the minus. Minus and a minus makes a plus. Between 5 and 3, and now all we've actually got to do is to stick those values in. So that's going to give me, if I'm putting 5 in, I'm going to get 50e to the 5 minus 20e to the 5 plus 4e to the 5 minus, and then putting 3 in is 18e to the 3 minus 12e to the 3 plus 4e to the 3, and that tidies up to 34e to the 5 minus 10e to the 3. I'm assuming it will just say, give the exact value and give my answer in its simplest form. Yeah, that's absolutely fine. So that's the second part of that one done. So fairly substantial integration question, just checking integration by parts and integration by substitution. But that should all really make sense to you.